Welcome to the Complete Chapter Masterclass on Current Electricity, a special video for Class 12th Board, JEE, NEET, and government exams. We begin with the basics, exploring what electric current is and its microscopic cause. Electric current is defined as the rate of flow of electric charge, with the SI unit being ampere. Although it has a direction from positive to negative, it is a scalar quantity, as it doesn't follow the rules of vector addition. The relation between current and drift velocity is given by I equals NA versus sub dE. Here, N is the number density of electrons, A is the cross-sectional area, and E is the charge on one electron. Ohm's law states that if the physical conditions like temperature remain constant, the potential difference is directly proportional to the current flowing through a conductor, giving us V equals IR. Resistance depends on the length and cross-sectional area of the conductor, while resistivity depends only on the nature of the material and temperature, not on the conductor's dimensions. The color code for carbon resistors is crucial for electronics. The sequence of colors from 0 to 9 is represented by the mnemonic BBROY of Great Britain had a very good wife, with the first two bands for significant figures and the third for the multiplier. Temperature dependence affects conductors and semiconductors differently. In conductors, resistance increases with temperature. In semiconductors, resistance decreases as more electrons become free. The formula for resistance is R sub T equals R sub 0 times 1 plus alpha delta T. Next, we will cover the combinations of resistors in series and parallel, and discuss electrical energy. In series, the current remains the same, but the voltage is divided, and the equivalent resistance is the sum of individual resistances. In parallel, the voltage is the same, but the current divides, and the reciprocal of equivalent resistance is the sum of the reciprocals of individual resistances. Electric power is the rate at which electrical energy is consumed, with the SI unit being watt. Power can be calculated as P equals VI, I squared R, or V squared over R. The commercial unit of energy is the kilowatt hour, or unit, where 1 kilowatt hour equals 3.6 times 10 to the power of 6 joules. Now let's look at cells and internal resistance and understand how a battery works and what EMF is. Electromotive force, E, is the maximum potential difference in an open circuit. Internal resistance, R, is the obstruction offered by the electrolyte. Terminal voltage, V, is the voltage across the terminals in a closed circuit, and V equals E minus IR during discharge. The combination of cells in series, parallel, and mixed arrangements affects the equivalent EMF and equivalent internal resistance. Refer to the table for the formulas for each combination type. Finally, we will study Kirchhoff's laws, which provide rules for solving complex circuits, and look at related instruments. Kirchhoff's laws include the junction rule, or KCL, based on the conservation of charge, and the loop rule, or KVL, based on the conservation of energy. The Wheatstone bridge is a special arrangement of 4 resistors used to find unknown resistance. It is balanced when no current flows through the galvanometer, where the ratio of resistances P over Q equals R over S. This principle is the basis for the meter bridge. The meter bridge works on the Wheatstone bridge principle, using a 1-meter wire. The potentiometer is an ideal voltmeter that draws 0 current. Its uses include comparing the EMFs of 2 cells and finding the internal resistance of a cell. Joule's law of heating states that heat generated in a wire is directly proportional to the square of the current, the resistance, and the time. It has applications in devices like electric heaters and fuse wires. Here is a summary of key concepts and exam tips. Remember that KCL is based on the conservation of charge and KVL on the conservation of energy. Resistivity depends only on material and temperature. The chapter on current electricity, from basic to advanced concepts, is now complete. Keep practicing numerical problems to master the topic.